Welcome back to OK Calculus. Last time we discussed the tangent lines and normal lines. This time I'm doing something a little different. There are still some things that you don't know how to take the derivative of, and so I'm going to take this time in this video to show you how to do those derivatives. So the first one that you will have no idea how to do is if they asked you take the derivative of ln x, which is short for natural log of x. And the simple way, we're actually going to replace this x with a u. So ln u. So natural log of u. They may ask you to take the derivative of this, and you'll have no idea how to do it. So this is the rule for it. So it's u prime over u. That's the basic premise. So basically what that means is you take the derivative of the inside function and then you put it on top, but then you take that same function and you put it on the bottom. So I guess it may not make too much sense, so let's go into an example here. So let's try ln x. Just ln x, just place u with x. So following that rule, we take the derivative first, so u prime over u. So the derivative of that is u prime. Take the derivative of x, which is just 1 divided by u, just the x. 1 over x. That's the answer. Alright, and then another problem. Let's try it. ln 2x. You might actually expect to get a different answer, but let's see what we get when we do it with this one. So u prime over u. That's the rule. So u prime, that's just derivative of 2x. So 2 divided by u. 2x. That actually gives you 1 over x once you simplify it. Gets you the same exact answer. Believe it or not. And now for the third example, this one will actually not give you the same answer, is natural log of x squared plus 2x. Let me put that parentheses. So we got that one, and then that one. So we got to take u prime over u. Follow the same rule no matter what it is. So u prime is, using power rule, 2x plus 2 divided by just the u. And that's what you get. 2x plus 2 divided by x squared plus 2x, and that doesn't really condense to anything else, so that is your answer. Natural log's pretty simple, but the next one is actually almost simpler. Alright, so our next example you will have no idea how to take the derivative of is e to the x. Now, e is not a variable, it's actually a number. It's like 2.7 something, so it's actually a number of its own. It's kind of like pi. But yes, there are easy rules for taking the derivative of this one, which e to the x, and once again, if we replace this with u, the rule would just be e to the u times, let me put parentheses actually, times du, or derivative of u. So in other words, you basically take e to the u and then multiply it by the derivative of that top, the exponent. So e to the x, how would you take the derivative of that? So e to the u, du. So e to the u, that's just e to the x times the derivative of the exponent. The derivative of x is just 1 times 1. Well, that doesn't really do anything, so it's just e to the x. The derivative of e to the x is e to the x. It's kind of weird, actually. It's the only function that's its derivative is itself. But obviously, it's not going to be that easy every time. So there's other problems, like e to the 2x. This one is the derivative is not just e to the 2x. You got to do e to the u. So e to the u is 2x. e to the 2x, times du, derivative of 2x is 2. So 2e to the 2x would be the answer. Alright, and then the last example I'll do for this is 2e to the negative x. There's actually something up front now. Makes it not too much more complicated actually. So you just do 2 times e to the u du. So e to the u, e to the negative x, and the derivative of negative x is negative 1. So instead of just times by negative 1, I'll just do that. Put a negative outside, and that is the answer. Pretty simple. And that about does it for some of the tricky derivative things you might not have known how to do. And there's basic rules on how to find them. Thanks for watching.